Now, we've just seen an example of a large test cell from Jacobs, where they used LabVIEW and PXI in a wind tunnel to improve the reliability and safety of large vehicles that are operating under harsh weather conditions. So now, in a smaller scale laboratory test, to talk to us about how they're using LabVIEW and compact DAC to dramatically reduce the occurrence of concussions in children, athletes, and soldiers. Please welcome to the stage Dr. John Lloyd from Brains Incorporated and Tommy Glicker from NI. Welcome.
Good morning, Chad.
Good morning.
Good morning, Mike.
Morning, John. Thanks for joining us. So tell us a little bit about your background and what you do.
Well, I'm a biomechanist. My field of research is biomechanics of the brain. That means I study how mechanical forces cause injuries to the head and brain. Now, there are two key forces at play. Firstly, there are linear forces. Those are the ones responsible for causing visible injuries such as bruising and skull fractures. But secondly, there are rotational forces. Those are the ones that cause invisible injuries such as concussions and brain injury. Now, current helmet testing technologies measure, of course, the linear forces. However, at this time, they don't measure the rotational forces. Consequently, we have helmets for various sports, including football, that are not tested against their ability to provide protection from concussions and brain injury.
So John, what percentage of head impacts actually involve the rotational forces?
Well, all of them, Mike. Every impact will produce both linear forces and rotational forces.
Great, so tell us about the system that you've built.
So I've modified the standard apparatus that's used for testing helmets. Instead of the standard head form, I replaced that with a crash test dummy head and neck. So when the head form impacts the force plate, it will actually rotate. With sensors embedded at the center of mass of this head form, we're able to measure the linear acceleration as well as the angular motion of the head. Now I'm going to raise this up to a height of 2 meters. And when it drops, it will impact the force plate at a speed of 14 miles per hour.
All right, so brace yourself for an impact force of over 1,000 pounds, and count down with me. 3, 2, 1.
Ouch.
That's an impactful system.
That was an impact. Wow. Okay, so John, tell us about how you've used NI products in this system.
So my measurement apparatus includes sensors from several manufacturers. The angular rate sensors, which are used to measure those rotational forces, is a highly specialized sensor, and it has its own dedicated data acquisition hardware and software. Now, I don't need to tell you guys that trying to integrate data from different platforms is a challenge at best. With this system, with the head drop technology, the peak linear acceleration and the peak angular acceleration don't actually happen at the same time. So you can't just line up the data. There's actually a lag between those, and measuring that lag is a critical measurement in my research. Fortunately, with LabVIEW and compact DAC, I was able to acquire data from those sensors simultaneously and synchronize the data.
Yeah, now you were mentioning to me that you're actually a pretty big LabVIEW fan now, aren't you? Tell us about that.
I am, Mike. I was first introduced to LabVIEW in 1993. I use LabVIEW every day as a very powerful tool in my research. And using LabVIEW and compact DAC has actually allowed me to increase the efficiency of my research considerably. What used to take a week, I can now achieve in 1 day.
Okay, so now what's the next step with your findings?
Well, I've recently completed an extensive biomechanical study of 21 professional football helmets. And the results from that study are pretty alarming in terms of how little protection those football helmets provide against concussions and traumatic brain injuries. I presented these results recently at the American Academy of Neurology and their pending publication. Based on lessons learned from that study, I actually developed a new football helmet prototype using a patent-pending matrix of non-Newtonian materials. And when I tested the prototype football helmet with this apparatus, the results blew me away. Not only did these materials reduce the linear forces, but compared to a standard football helmet, they actually reduced the rotational forces that cause concussion and brain injury by an amazing 50%. This innovative technology has tremendous potential to prevent injuries as well as save lives.
Well, John, that's really great to hear about the... Well, we're really excited. You know, we always like to hear about the use of our products and technologies to be used to improve everyday life. And it certainly sounds like you're doing just that. So thank you very much for joining us this morning.
Thank you, Mike. Thank you, Chad.
All right, I'll briefly point out that both the Jacobs structural test system and the helmet drop system will be available on the expo hall floor later today. Now, John just demonstrated how you can greatly benefit from a tightly integrated data acquisition system. By combining multiple sensor types, signal conditioning, and I/O into a single platform, John was able to improve the accuracy and the synchronization of his measurements, advance our understanding of concussion injuries, and ultimately design a safer helmet. But John's not alone. You and NI have used LabVIEW and Compact DAC for thousands of applications around the world to accelerate your discovery process. And in conversations with you about those applications, you've asked us to integrate a PC with Compact DAC that is small and rugged enough to get out of the lab and into the field. And based on that feedback, I am pleased to announce today the new Compact DAC 4-slot controllers. Now, these controllers feature an integrated dual-core Intel Atom processor, removable SD storage, and integrated signal conditioning in a form factor that is ideal for field data logging applications.